Okay, let's start with a very quick code example. We're going to be discussing NaN, or not a number, in C#. If you code any scientific programs or any financial programs, you are likely to encounter NaN, and you should actually know how to deal with it. So let me start with a very quick code example. We're going to do some divisions. So I'm going to wrap my code in a try-catch block, and in case an exception happens, I'm going to write the message to the console so we can see what is going on. So we're going to discuss some very basic division, and we're going to see what the difference is when we use integers and when we use floating point division. So let's do that quickly. Okay, let's start with the integers. Very quick example. I have int 1 is 1 and int 0 is 0, and let's try to divide 1 by 0. Okay, equals, and we're going to print the result, and we're going to have console read line just to keep it clean. Well, let's see what happens. Let's run the code, and we get attempted to divide by 0, so we get an exception. Let me actually try to remember what the exception was called. It should be divide by 0 exception, so divide by 0 exception. So let's find out if I am right. Attempted to divide by 0, so this is the correct exception. So let's change the message quickly, just to demonstrate. And a message, and one final time. Divide by 0 exception, attempted to divide by 0. When I have integers and I try to divide by 0, I'm going to get an exception. Now let's see if this is the case when I have floating point numbers. So let's change this to doubles. I'm going to have double 1, and then I'm going to have double 0. And let's find out what happens. So are we going to get an exception? Not. Let me just do some generic exception here, just in case. Okay, generic exception. We're going to have chilmex and the message. So let's run the code and see what happens. And we actually get an infinity. And if I change the number from 1 to -1, okay, let's see if there is any difference, and we're getting negative infinity. So there is a difference when we're dividing by 0 using floating points, and when we divide by 0 when we're using integers and longs. So let me try to introduce quickly the concept of NaN. Let's see what is going to happen if we try to divide 0 by 0. And we get the result, which is not a number, NaN. This is our result. This is the line that prints the result to the console. Okay, let's quickly discuss what not a number is in C# and why do we need it. Okay, now let's go to the definition of a NaN, not a number in C#. This is a quick overview. You can pause the screen and read about it, but let me just quickly pinpoint some of the important aspects. NaN is a special floating point value used to represent undefined or unrepresentable results in floating point arithmetic. So this is where we're going to find it only in floating point arithmetic, and it is likely to show up in computations involving floating point types such as double or float, when you divide 0 by 0, as we saw in the example, when you take the square root of a negative number, and so on. And you can see why do we need NaN, how does it help us, and what do you need to watch for. So I'm going to cover some of these in my next code examples. Again, if you want to read the overview, you can pause the screen and do so now. Okay, let's quickly take a look at another case where we can get a not a number when you try to actually get the square root of a negative number. So let me change the code quickly. I'm going to remove this. Okay, let's first test with positive number 4. The result is math square root of 4, and this should give us 2. So let's run the code, and you see the square root of 4 is actually 2, and if we try to get the square root of -4, we should get a none. Let's run the code again, and we get not a number, and you can also test if the result, let's make a double, is not a number, and let's do that here. Result is none, and here double is none, and what is it? Result is none result, and let's run it, and we should see result is not a number, which is actually true. Okay, what else can we check quickly? None does not compare equal to itself. Let's test that. We have our result, so let's change this to okay, result equals result, and it should give us false, and you see it is false. And if I change this to a positive number, the result of course should be true. So this is something else to watch out for. None equals none returns false. And what else is there? Okay, let's test this part here. When you try to see if not a number is smaller than 5, we should get false, and weirdly enough, if not a number is greater than 5, should also return false. So let's try to do that. Greater than 5 and smaller than 5. We should get false, false. Let's run it. And we get false, false. And this was the last code example. Basically, none might not show up too often in your code, but if you're dealing with some floating point operations or some financial applications, you should be aware that it exists and how it behaves. And in that case, you should always check for none using double none or float is none and handle the result appropriately. And that is all from me for today. Thank you for watching.